el OK.
Let me know when we are in the YouTube streaming, okay?
Me indica que ya empezó la transmisión. OK.
Okay. Good afternoon to everyone of the participants of this Congress. It's pleasant for us to present the Congress speaker, Horacio Fernandez. Horacio Fernandez is an associate professor in the IST, Instituto Superior Técnico of Lisboa. Also is a researcher in the field of nuclear physics. Currently, Horacio is the coordinator of the World Pendulum Alliance project who motivated this Congress. Horacio, we have had more than 1,000 participants in this Congress. This is a sample of the success of the World Pendulum Alliance project, whose main objective is to improve the quality of education and access for all. And welcome to this Congress, and thanks for all your help in the project to our university, UNAD. Okay.
Thank you very much for your kind words, Carolina. It's a pleasure for me to share with you the experience that we have gained in these 4 years with the World Pendulum Alliance and with the whole experimental setups that we have spread along several latitudes, most of them in Latin America. And so I have prepared my presentation in such a way that I will not focus exactly in the full project, but I think because you have done a great job joining and convene all these 100 people in this Congress, and because they are probably professors that are angered to explore the pendulums and the physics behind it. So I will focus more on the didactics of what we have done instead of just deploying numbers about our work in the last 4 years. So I'll just give you an insight what will be the World Pendulum Alliance and try to unveil, because of that, some studies around a real experiment, because there is always a possibility for everybody to run applets and simulations on the net, but I tried to highlight what can be done with a remote experiment or a real experiment instead of simulations, okay? And so I'll try to unveil that for most of the people. So the World Pendulum Alliance basically is the result, is one of the outcomes of the Erasmus capacity building financed by the European Commission. The project originally was the World Pen at ELAB, and ELAB stands for a remote laboratory or remote control laboratory that already existed in IST since 2000. And basically what will come up from this project will be during the coming years will be this informal association of associations where we try to get new partners as well. And the idea behind this is to have a global experiment running in several latitudes where people can see the difference between every latitude of the gravity. So gravity, as most of you will know for earlier school, varies with latitude due to the effect of the centrifugal force of the Earth. And because on the equator, we are farther from in the poles, so our speed is much higher in the equator. This tends to reduce the gravity because we feel an external force that tries to pull us from Earth. And so the idea was to conceive an experiment that could be capable of measure this difference, but can be used as well as a tool for teaching, because the pendulum is one of the experiments that I always stress that almost all mechanics can be taught around the pendulum. So on this network, by now we have not only our universities from Latin America, from Chile, Panama, Brazil, and Colombia, mostly of them, but some overseas Portuguese schools like São Tomé, Maputo and Dili, so in East Timor, Mozambique and São Tomé and Príncipe, and some European partners that have collaborated with us on the spread of this project. This is basically capacity building, so we have tried to give some best practices that we have already in our universities, and these are colleagues from France, Czech Republic and Spain. But we have already gained these added partners, that's what we have called associated partners. Some of them are other than Latin America, like the University of Cape Verde, and some science centers that are not hosted on the universities, but basically they are like museums or any other institutions that have a more close connection with the society, where the pendulums can be visited. I just put here a very recent analytics of our project. In the past, the eLab was mostly used by India and is still. So this is really normally not a surprise because they have a lot of inhabitants and they speak English. So it's easy for them to try to find contents to teach physics in the internet, because they lack on a good education schools in the country. But what can be seen, and I have put here in orange, these are the newcomers, because like before the project, Pakistan, for instance, and even the United States. So Pakistan was the second hit, but some of these countries from Latin America were completely absent from the usage of our remote lab. And presently, they have surpassed Pakistan. That was the second one 4 years ago. And we have another interesting point here that I think this is not motivated by our project, but because of the COVID, are newcomers like the United States and China that in the past didn't show up in our analytics. And this is quite interesting because this just is a confirmation that our project is being used in Latin America and on the Americas as well. But what have we done? Basically, we have this remote experiment that was just an implementation of our old remote experiment controller that is called, it was a Java application that was used to set up the first primary network, what we have called the primary network of pendulums, that are pendulums that are precisely on all these latitudes from Czech Republic to Punta Arenas, that is another associated partner in Chile, so from 50 north to 50 south. But we have developed a little bit further because we, during the first year of our project, we recognized that most of the people in Latin America, like in Brazil, for instance, we have a deep study on that, only 50% of the students, so 1/2, could not reach a computer, and only, or a majority, a great majority, like 15%, has their own computer at home. So this means that we need to develop a new platform that was the free framework for remote experiments in education that could be used not in a computer, as the former Java application was, but could be used in a regular cell phone, for instance. So, and this, it was a little bit demand. We have developed it in low code so people could easily implement in their own universities with authentication. So the user now is authenticated. We will allow in the near future to connect this remote lab with any kind of learning management system, such as Moodle. So for instance, UNAD can, one of these days, having Moodle with some questions for assessment running and asking for the students to go to the free to do a certain experiment, and we will analyze the data coming from the experiment and check if the answer in the Moodle is correct or wrong. So this will permit for the first time, at least to my knowledge, to have a really a massive open online laboratory where people are directly assessed by the platform. So completely automatic, without any intervention of the professor on this more, I'd say, boring task of assessment. And so this will be completely automatic. And then by now, all the secondary network that are at a regional level, for instance, the pendulums that belongs to UNAD or the pendulums that belongs to UNIANDES, they are already in this new software. And so will be a strong push for the future LLab infrastructure that in the end will be like a federation of all our remote control laboratories. So anyone from UNAD will easily, through the server of UNAD, access any other server and then access a particular experiment that are not hosted, for instance, in Colombia, can be in Panama, can be in Chile, can be in Europe. So this is the present interface where you can see the apparatus type. So we aim that in the near future, the schools will offer not only the pendulum, but other kind of experiments as we have in IST, some of them advanced, and with the possibility, you see here that one kind of experiment can have 2 or 3 protocols. So it's not mandatory that a particular experiment just can run a certain type of experiments. You can do other types of experiments according to the protocol that are being implemented. So if you have an oscilloscope, you can use it for several things. It's not just for a certain kind of experiments. So this is basically the last type of pendulum that we have set up in Dili. As I was telling you, all our partners have at least 11 versions of this pendulum, and we just launched a bob with typically 2 kilograms, and this allows the measurement with very high accuracy of the local gravity. And this is exactly what is the project, in particular this part of the project for. Basically, the local gravity is in this graph I show you. Some was really in the beginning with even lacking on a very precise calibration. You can see already that we have like a trend that follows the harmonics of the G meaning the acceleration of gravity, local acceleration of gravity. And you can see, for instance, several spots where it is even a little bit weaker, because, for instance, in Bogota, you are at 2,000 meters of altitude. And so you need to correct not only because of the centrifugal force, because you are very close to the equator, but as well because of the height, and you are a little bit far from the center of the Earth. And so the distance is higher to the whole mass of the Earth, and you feel a relative or a very small amount on the reduction on the gravity. But in measured times, you see that the blue dots are measurements. Of course, the G simulated by Wolfram Alpha, for instance, there are a lot of platforms online that can provide you the G in terms of the latitude. You will see that this follows a certain line that is adequate for the surface of the sea, but of course there are points that are not on the sea surface, and they are spread around in altitude as well. So this can allow the students to interpret in several ways how gravity varies with latitude. But of course, our pendulum can be used just a normal pendulum in class. And so we have developed a MOOC where we have all these phenomena tested in class. And so we can start with the simple pendulum, where is the mathematical one, where we have just the period that is proportional to L and G, but we can go a little bit further and explain the momentum of inertia with the pendulum and try to have the first order correction, because notice that we are measuring with a very high accuracy. So it's typically 0.3 parts per 1,000. So 0.03%. So, and because we have this such precision, we can detect this variation on the period due, for instance, the momentum of inertia. Although we have designed the pendulum trying to avoid these corrections, this is the first step, is to do this physical correction to the period. Then we can do another one. We can go further and test for instance, you know that the pendulum is derived from a differential equation. Normally, we do an approach that is saying that the sinus can be approximated by theta, so sinus theta equal theta, but you can use eventually other orders of magnitude to determine the exact period and do such corrections to the period. Although this is not really the main object of my talk, I just want to explain as well, because we are measuring the velocity by the transit time in the photogate, so we can accurately measure the velocity because there is an occlusion of the photogate, and during this occlusion time, if I know the diameter, I will know very precisely the velocity. So I can introduce, for instance, this principle of transit time using, for instance, the exoplanets, okay? So it's exactly the same when we have an exoplanet. What happens is that there is a little bit fade of the light of the star. Exactly in this case, we just could cut all the light that is coming from the laser, but is basically the same principle, and we can detect the velocity of the planet, and here we will detect the velocity of the bulb exactly on the origin where the speed is higher. So we can do eventually an explanation for the students that because the cosine of theta there is 1, is not so critical where is the position of the photocell, because I'm going to have always a very good reading of my signal. But every cloud has always a silver lining. And when we were doing these experiments, we could determine, because again of this very intense signal of the photogate and the precision that we need to check for the latitude, we have secondary effect. That is when we saw the determination of the transit time at origin, we could see some fluctuations. Okay, so if I try to adjust, you'll see that there is very small fluctuations on this velocity, and we try to investigate there, and this can be an investigation process for your students or grounds for investigation what was going on. And what was going on was two kinds of fluctuations. One that was due to the precession, so we start to have like a Coriolis force, and then we have some precession that gives us a very long period error, but we have as well smaller periods of oscillations that in the end we discovered that was basically because of the torsion of the bulb. And so this could lead us to interpret these detailed fluctuations as a possibility for the students to query what was going on. So try to find out what was the problem, if it was a edge detection of the photogate, and how we could mitigate if it was a systematic error. But what happens in the end is that this is a very precise frequency. So if I do a frequency analysis of the signals, I have a peak here, and this peak is related with this oscillation of the bulb, okay? And what happens is that basically if you consider the equatorial plane of our sphere as a little bit elliptical, you will see that during the transit time in the origin, I'm going to see different diameters, because if this was an ellipse, but don't forget that this is just a very small difference in the ellipse. It's basically in the order of 100 of micrometers or even less. But because again, we are measuring the time with such precision, we could detect this fluctuation on the velocity, okay? And so what we figured out is that there is this very low frequency movement was basically an oscillation of the cable and the sphere, and it was basically a torsion pendulum. So we can use our research project as well, not only for measure the variation of the G with the latitude, but as well to introduce what is the torsion pendulum and see how does the frequency that we are measuring can lead us to the precise measurement of the rigidity module of the wire. So we have a wire, the wire is typically in the order of 400 micrometers. And so by using these numbers, we can extract and check that the modulus of rigidity was exactly what was expected for our alloy, that is basically a nickel chromium alloy. And this alloy is typically in the order of several 90, 60, 90 gigapascal of rigidity module. So again, one thing that we have discovered with the remote experiment that could not be never modulated or modeled if we have like a simulation that we can see on the internet. Another study that can be performed is that you know that gravity, the second order of influence of the gravity on Earth is basically induced by the moon. So we have in the first order of, we have all these phenomena of the rotating Earth, the little bit different in diameter between poles and the equator of the Earth. But the second order is the influence of the sun and the moon that everybody knows that generate tides, at least people that live by the sea. But we could detect as well, we have precision enough in our pendulum to detect the influence of these tides. And this can be quite interesting because a student in Bogota that doesn't have sea can detect a tide, a gravitational tide in Bogota or any other part in the interior of any continent. And so we could very easily see, of course, this has to be consecutively pretty during the day and during the months, because you know that depending on the alignment of the sun and the moon, the gravity effect, the gravitational effect on the Earth is different, okay? But it can be used as well to show to the students how this three-body structure of our solar system influence our gravity on Earth and why there is during the day the variation of the gravity that induces the tides on the sea. And they move this huge amount of water in the sea, which is not something really small, I have to say. So this can be done by two ways. One is to use, again, the fast Fourier transform to detect these frequencies along the month, for instance, or during 1 or 2 days. We have tried this with more intensity when, of course, we have a spring tide, that is when the tides are higher, because the moon is aligned with the Earth and with the sun. And so the force that tries to pull us is a little bit higher. So we have a reduction on the gravity that is more sensitive during these days of full moon or new moon than in the other days of the solar cycle. And we can use this as well for the students to perform some numeric data analysis of the signal. For instance, I'm showing you here is the autocorrelation of the signal to show that this behavior is periodically. We have different days, and we can see that every 14 days we see this periodic behavior, which means that there are some correlation with the tides that we see on the sea. And so we can measure this quite well with autocorrelation. Of course, if we go in this way, because we are measuring with very high precision the velocity in the origin, depending on the launching position of the bob, I can make some energy conservation studies as well. So using the pendulum not only to study the variation with latitude and all the things I have speaking about, but as well to give an insight about conservation of energy, because if I launch in a certain position by knowing exactly which was the weight, so I know the potential energy from the launching, and then this energy will be converted, and in the origin, I will lose all the potential energy, and I will have only kinetic energy. And because I'm measuring this velocity, I can understand how the potential energy is converted in kinetic energy, and again to potential energy when the bob stops. And of course, in this position, I know that there is no velocity because it's in the extremes of the pendulum. So this even allows us to measure indirectly the G, because if I do now a map or a graphic where I plot the square of the velocity according to different weights of the launch of the pendulum, I can have a graph with V square in function of the height of the launching, and so I can retrieve 2G directly from the graphic. So I have another way to detect. Of course, this is not so precise because it's not the resonant system like we have when we have like oscillation of the pendulum, and we are measuring like 100 cycles, so that's why it's so precise. But by doing this energy conservation model, I can extract and understand how this model can give me a local measurement of the gravity, but now the precision is really, how can I say, it's not so precise because the weight of the launch is measured with some errors that are in the order of 5%. So I don't have now 0.03% of precision. And we can as well, yes?
We have now, sorry, 2 minutes.
3 minutes, yes, I have my clock here. So I'm just going to the conclusions. So what we have here is that I can see as well in time the attenuation during the full, how can I say, relaxation of the pendulum, so I can study additionally some friction components that are involved on this pendulum. So I just, another thing that we are measuring is the temperature, so we can correlate the temperature with the weight, because there is eventually some distension of the wire due to the temperature, because you know that metals are subject to this distension of the length because of the heat or the temperature. So I can as well use this almost like a thermodynamic experiment to check for this variation. So I'm not going to go in the instrumentation part, because again, we have more studies that we can use. In particular, one very interesting thing, because the pendulum itself is a proxy of the time, so I can use the pendulum as a calibrated time and check for the variation of the clock of the microprocessor, and this can be done as well. But just to conclude, and with the good things and bad things that the experiment have done during all this time, just in summary, I just want to highlight that this capacity building was really a way to merge together a lot of colleagues from all the continent, Europe and Latin America. I think now we have understood, and there is papers already presented in Panama where we can determine that the precision was sufficient enough to measure these things. Another thing that I want to highlight is that, conversely, to simulations, these second-order effects can be measured, and some hidden physics can be observed and highlighted for the students, and this can be a strong motivation for inquired learning spaces that we can do with students, and eventually using flipped classrooms to bring these aspects when teaching. The last thing I would like to say is that this World Pendulum Alliance is basically a global network for teaching experiments in physics, and I strongly hope that our colleagues from these universities will bring you more experiments in the future. So now they have the knowledge, they have the software, they have the capacity to bring more experiments live, and in particular in a university like yours that is at distance and open, should be a must for the forthcoming years, to have other experiments that people can use, not only in physics, but as well in chemistry or other fields of engineering. Thank you very much, Carolina. So now I open questions if there is time.
Okay, thanks Thanks a lot for your presentation, Horacio. Yes, we have 2 questions of our participants. The first question is about what is the manner of a professor of an institution can access to this kind of remote laboratories.
So, Carolina, just one thing. I'm reading the questions in the chat. Is that correct?
Okay. Yes.
So, you didn't start with question Yun, did you? Because we have 4 in the chat.
Okay. Yes, we are. Probably I am not updated my YouTube, and then I am seeing only 2.
Okay. So I'm looking on the Zoom. So the first question is a professor that is an institution that doesn't belong to the Alliance, how can join the remote experiments? So there is two questions here, I suppose. One is all the experiments that are provided now, because of our commitment with Europe, with the Commission, they are open, so everybody can use these. And that's why I show you that India is using more than any of our partners the network, okay? So this is the first point. The second is now if another university plan or are willing to have the experiment or using the software and needs assistance, they can contact one of the partners and become an associated partner of the Alliance. And then they will become a provider as well of this experiment or other experiments. And we have such cases in Brazil, for instance, and even, for instance, in Bogota, Maloca Center is associated partner of Uniandes. So this is another possibility. Typically, this has to be official if there is material that are from one university leads to the other one. So the other question that I have here is, what is the maximum error in the pendulum experiment? In our case, the error or the uncertainty of measurement of the gate is around 0.03%. But the wire is measured with the order of half of a millimeter. So, and this is the main error that we have on the absolute measurement. But for the tides, we just need the differential measurement. And for that end, it's enough the precision of the clock, because the length, we just correct it by the thermal expansion. And this gives you in the order of 1 part in 1,000, which is enough to detect the tides. The third question that I have is, what does gravity influence in the physics experiments? Basically, what we have is typically the period, as I have shown you in my equations, the period depends on the length and on the local gravity. So if we do the reverse, we will see that the gravity in the case of the pendulum is strongly dependent on the length of the cable and on the time that is one oscillation of the pendulum. So and this gives you the resulting G, force locally, okay? The last one that I have here is, do pendulums up to what angle of release give a faithful result? Okay, this is a good question, but I have to say that in our case, because the length is around 3 meters, there is no influence at all, because the second order correction is even less than the correction that I show you about the momentum of inertia of the physical pendulum. So we have here 2 things to approach the results. One is just to use the simple pendulum math, and that is enough for most of the measurements, at least to see the difference in latitude and things like that. If we want to have a more accurate measurement, we have to have really small movements. We have one pendulum, for instance, here in Lisbon with 8 meters, and you see that 50, even if you use the 20 centimeters, is almost nothing regarding to the 8 meters. But typically the difference starts when you have more than 10 degrees, and this is never happens in our case, okay? Because we have typically it's from 2.8 to 3 meters, the usual length, and then we just have a movement of the order of 15 centimeters or 20 centimeters, which is not enough to deviate the results in an order of magnitude that affects the reading of the local G. And I don't have more questions in my chat, at least. I'm not following the YouTube, so I don't know if there is questions different from these 4 in the YouTube.
That's all the questions in YouTube. And then again, thanks a lot, Horacio, for your presentation, and welcome to the next Congress, probably the next year. Okay, thanks so much.
I hope to be live if I can. Thank you very much for the invitation, and all the best for all of you.
Thanks.
Muy bien, continuamos con el tercer y último día del 1er Congreso Internacional de Investigación y Enseñanza de la Física 2022 de la Sala 3. Recordemos, la temática es tópicos de enseñanza de la física. La siguiente ponencia será a cargo del doctor Johnny Paul Zavala de Paz, profesor investigador de la Universidad Politécnica de Querétaro, miembro del Sistema Nacional de Investigadores Nivel 1 CIIEF, áreas de investigación en aplicaciones computacionales para reconstrucción 3D, procesamiento de señales, sistema de visión y sistemas embebidos aplicados. Lo acompañan en la investigación José Amílcar Rizo Sierra, Eli Karina Anaya Rivera, César Augusto Izaza Borges y Cristian Felipe Ramírez Gutiérrez. Su ponencia titula Proyectos Integradores, un aprendizaje basado en la construcción de prototipos en la enseñanza de la ingeniería. Una bienvenida para el doctor Zavala.
Sí, muchas gracias, Carlos. ¿Me escuchan?
Sí, señor, le escuchamos perfectamente.
Sí,
¿puede iniciar
gracias.
la presentación para que veamos los slides? Le recuerdo que tiene 25 minutos para su importante ponencia, y a los asistentes que durante la ponencia pueden realizar las preguntas a través del YouTube, para que al final tengamos 5 minutos y que el doctor Zavala pueda responder a estas inquietudes de manera oportuna. Doctor Zavala, bienvenido al Congreso y puede proseguir con su presentación.
Muchas gracias, Carlos. Muchas gracias. Bueno, pues antes que nada, pues agradezco mucho la invitación y bueno, pues el apoyo de estar aquí con ustedes. Bueno, creo que ya se puede ver mi presentación, ¿verdad? ¿Ya la pueden por allí visualizar? ¿Es correcto? Perfecto. Bien, entonces, bueno, vamos a iniciar con esta ponencia, que es Proyectos Integradores, un aprendizaje en la construcción de prototipos en la enseñanza de la ingeniería. Como bien lo comentaba hace un momento Carlos, bueno, pertenezco a la Universidad Politécnica de Querétaro, en el cual estoy en un área de ingeniería, y bueno, nosotros prácticamente pues nos enfocamos a ingeniería aplicada en un programa que es multidisciplinario. Y bueno, pues ahorita lo vamos a comentar. El contenido de esta presentación, primeramente introducción, objetivo, metodología, resultados y conclusión. Bien, entonces hablando un poco sobre el proyecto indicador, bueno, pues desde hace ya algunos años, pues es un tema que se ha venido trabajando con diferentes temáticas, ¿sí? Dependiendo pues el perfil del estudiante de ingeniería, ¿no? El cual pues ellos desarrollan competencias relacionadas con gestión, con planeación, socialización, ejecución, roles y funciones en los que cada uno de ellos pues permiten que a través de cada uno de esas competencias pues puedan ellos aplicarlos, ¿no? Es una metodología que pues, actualmente trata de involucrar no solo a un solo perfil de ingeniería, sino de manera multidisciplinaria, ¿sí? Entonces, el objetivo de esta presentación, y bueno, de compartirles a ustedes de lo que nosotros hacemos parte aquí en la universidad, pues es desarrollar una metodología de enseñanza-aprendizaje basada en proyectos integradores mediante el diseño, construcción e implementación de prototipos o proyectos desarrollados que permitan desarrollar competencias en cada ciclo de formación a los estudiantes de Ingeniería en Redes Telecomunicaciones. Viendo que esta metodología se ha venido ya aplicando aquí en toda la universidad y verdaderamente pues, ha funcionado porque trabajamos nosotros en un modelo educativo basado en competencias, ¿sí? Y esto permite que los estudiantes pues, desarrollen sus competencias en base a esta metodología que les estoy mostrando, una que se basa en lo que es la formulación, la socialización, la planeación, la ejecución, el cierre o la evaluación de los proyectos. En la formulación, ¿qué es lo que se hace o se determina? Bueno, pues en la formulación se formulan prácticamente desde el inicio o el trabajo, ¿no? El trabajo en los equipos, quiénes van a trabajar, cómo van a trabajar, ¿sí? Definiendo el tema, el proyecto, ¿sí? Qué materiales son los que van a utilizar, desarrollar un programa, un plan de actividades para la ejecución del proyecto y por supuesto también lo que es el presupuesto de lo que es el proyecto, ¿no? Entonces, se pide también un documento protocolo para que pues, los estudiantes pues, puedan formalizar esta propuesta. Ellos desde un inicio pues, tienen para que puedan desarrollar durante su plan de trabajo, ¿no? En la socialización existe ahí ya la comunicación y los procesos en los que los estudiantes y los profesores pues, van a formar parte de la gestión de estos proyectos integradores. Si hablamos de una comunidad de un grupo de 30 estudiantes, pues se habrán formulado equipos de trabajo de 4 estudiantes, ¿sí? Máximo 4 estudiantes en los que ellos pues tienden a socializarse para el desarrollo de este proyecto, ¿sí? Y obviamente pues acompañados o asesorados por profesores del programa, ¿sí? Posteriormente viene lo que es la planeación. La planeación logra pues está basado en un diagnóstico donde se realiza ya la parte del diseño del proyecto, ¿sí? Por parte ya de los estudiantes con asesoría del profesor. Esto, bueno, pues va implicando que se realice ya sea un estudio de mercado, ¿sí? Acerca de cómo se encuentra el proyecto, ¿sí? Cómo sería en un futuro del proyecto, cuáles serían como sus áreas de oportunidad o dónde va a encajar el proyecto una vez que sea terminado, y va a ser en una empresa, tipo, sea industrial, si va a atacar alguna necesidad, algún problema de tipo social, ¿sí? O comunitario, etc. Ellos realizan una investigación de campo para poder planear lo que es la ejecución del proyecto. Una vez que tiene la planeación, viene lo que es la ejecución. La ejecución pues, es el desarrollo de esa planeación, es la ejecución del proyecto, ¿sí? Donde viene la parte de la implementación y la construcción del modelo propuesto, ¿no? Este modelo pues, tiene una duración aproximadamente de una ejecución de 4 meses, ¿no? De 3 a 4 meses es lo que de acuerdo al calendario, por el tipo de periodo que se maneja en la institución, que es por periodo cuatrimestral, permite que los estudiantes en 3, máximo 4 meses ejecuten el proyecto, ¿sí? Entonces, obviamente la planeación, el cronograma de actividades, su plan de trabajo, tiene que ir acorde a los tiempos, ¿sí? Obviamente asesorados por algún profesor, ¿no? Entonces, En la ejecución, bueno, pues el asesor profesor va guiando a estos estudiantes para ir verificando, corroborando que las competencias que el estudiante ya adquirió durante el ciclo de formación. Estamos hablando que un ciclo de formación aquí nosotros es prácticamente un año. Durante la estancia que tiene el estudiante aquí en la universidad son 3 ciclos de formación, es decir, son periodos cuatrimestrales, tenemos 9 cuatrimestres. Los primeros 3 cuatrimestres es un ciclo, el segundo ciclo, los siguientes 3 y los últimos tercer ciclo de formación. Esto permite, bueno, pues que en cada ciclo de formación los estudiantes vayan aplicando las competencias obtenidas durante su aprendizaje o desarrollo académico. ¿Okay? Finalmente viene lo que es el cierre. El cierre de este proyecto viene lo que es la entrega ya final del proyecto, del trabajo, en la que ellos pues, prácticamente pues, tienen la aprobación de que ha sido concluido por parte del asesor y el cumplimiento de las especificaciones y de requisitos que en su momento o al inicio se plantearon. ¿Okay? Conforme a este cierre viene la parte de divulgación. Esto es algo muy, muy importante porque los alumnos vienen a presentar finalmente el proyecto, lo vienen exponiendo, lo vienen ya prácticamente explicando a través de eventos, una feria, exposiciones, etc. Esto permite, bueno, que el estudiante pues vaya enrolándose en cuanto a su desarrollo profesional. Esta metodología, bueno, ha permitido que nuestros estudiantes apliquen todas las áreas. Si el estudiante lleva materias de área de ciencia básica, tiene que aplicar las competencias de esas materias en el proyecto. Si el estudiante lleva materias de desarrollo humano, tiene que aplicar las competencias de esa materia en el proyecto. Entonces, esto ha permitido, bueno, que el estudiante tenga una formación más integral en todas las áreas. ¿Sí? Ahorita lo que se está trabajando actualmente es que los equipos de trabajo sean ahora multidisciplinarios, no solamente de un solo programa educativo, sino que involucren otros programas educativos que existen en la universidad, desde carreras como licenciatura en negocio, licenciatura en administración y gestión empresarial, ingeniería de manufactura, ingeniería mecatrónica, ¿sí? Ingeniería automotriz, ingeniería en sistemas computacionales y, bueno, por supuesto, la carrera de ingeniería en redes de telecomunicaciones. Entonces, y muy importante aquí, bueno, pues la parte del docente. El docente, aquí la parte del rol docente es una participación en la que el docente pues apoya al alumno a construir y desarrollar en base a sus competencias, ¿sí? Hacer que el alumno conozca o tenga nueva información, hacer conexión, enriquecer el concepto o experiencia en la universidad, para que el día de mañana, cuando los estudiantes vayan hacia la industria, ellos sepan cómo desarrollarse, desenvolverse allá de manera externa, ¿no? ¿Sí? El rol docente, bueno, pues también sirve como apoyo, sirve de asesor, evaluador, ¿sí? Mediador, coordinador de estos proyectos, lo cual se centra básicamente en los estudiantes. Estos, pues, en base a estas fases, en base a algunas fases, como son activación del conocimiento, el alumno adquiera conocimiento, comprende el conocimiento, ¿sí? Usa y aplica el conocimiento, reflejar ese conocimiento, ¿sí? Porque el día de mañana, como les comentaba, el estudiante tiene que ir a la industria, ir al exterior, una vez que egresa y poder aplicar estas competencias. Dentro de los resultados que hemos finalmente obtenidos, pues aquí en estas imágenes se presentan las presentaciones, exposiciones de cada uno de los proyectos en los cuales fueron ejecutados a través de este proyectador, el cual ellos presentan sus resultados, sus metodologías, sus investigaciones, sus prototipos desarrollados, ¿sí? Lo que hacen, bueno, que a través de una presentación, una exposición, pues ellos permiten expresar los resultados y cómo lo fueron resolviendo, ¿no? Desde la construcción del prototipo, pues, en el cual ellos vienen ejecutando en 3-4 meses, ¿sí? En máximo 4 meses, se va verificando que cada uno de estos proyectos pues, se vaya finalmente concluyendo, ¿no? Hemos llegado a tener finalmente participación de estos proyectos durante algunos eventos, ya sea nacional e internacional, en donde ellos van y muestran cada uno de los dispositivos o proyectos obtenidos. Bien, bueno, pues, dentro de estos resultados, muchos de estos prototipos son presentados también en ferias de ciencias hacia estudiantes de la educación básica, educación media superior, secundaria, preparatoria, ¿sí? Los cuales nos sirve para que los estudiantes que vienen en preparatoria pues sepan o vean qué proyectos son los que nuestros estudiantes universitarios pues, desarrollan, ¿no? Bueno, pues dentro de pues, finalmente esta metodología pues, ha permitido implementar, ¿sí? Ha permitido implementar estos proyectos y de tal manera, bueno, evidenciar el nivel de desarrollo en conjunto de competencias en la que se involucran diferentes materias, ¿sí? Fundamentales en el proceso formativo y ejercicio profesional. Cabe mencionar también que conforme se van avanzando los ciclos de formación, el nivel de complejidad de estos proyectos va siendo mucho más grande, ¿no? Es decir, conforme los alumnos avanzan en sus periodos cuatrimestrales, van teniendo materias de especialidad, materias más acorde al área, dependiendo la especialidad, en los cuales pues, los proyectos este proyecto se vuelve más complejo, ¿no? Entonces, pues comentaba, esta metodología se ha implementado ya, se ha venido implementando ya en toda la institución, siendo que lo que se está actualmente aplicando es que ahora sean proyectos integradores multidisciplinarios. Quizás sea un reto para en el que los estudiantes pues ahora tendrán que involucrar compañeros de otras áreas, ¿no? Quizás a lo mejor ahora el asesor pues no solamente sea de una sola área de ingeniería, sino ahora sea de una licenciatura también, ¿no? Como les comentaba, licenciatura en negocios, licenciatura en administración, etcétera, y esto es lo que finalmente, bueno, pues les vengo a compartir, y bueno, pues creo que es una metodología que puede emplearse en cualquier institución, en cualquier universidad, y bueno, esperemos que pues pueda aplicarse, ¿no? Pues bueno, de mi parte, pues ha sido todo, y bueno, pues no sé si hay alguna pregunta, comentario, y bueno, pues muchas gracias.
Doctor Zavala, muchas gracias. Sí, hay una inquietud aquí. Dice, bueno, esto es muy a nivel de México, ¿no? Porque sabemos que es en el área donde usted está haciendo la investigación. ¿Cómo se está implementando esto a nivel de formación de docentes? O sea, sabemos que esto lo están haciendo de docente hacia estudiante, pero ¿cómo va la implementación de esa metodología para la educación de formadores?
Para la educación de formadores existe también, no le llamamos como tal proyecto integrador, porque pues, los docentes pues, no están como tal estudiando, ¿no? Pero sí proyectos en conjunto en cuerpos académicos. Sabemos que en las instituciones, universidades hay cuerpos académicos, y si nosotros llevamos esta metodología aplicando a una formación de profesores, creo que sí se puede implementar, ¿no? En el que aquí, por ejemplo, tenemos cuerpos académicos en diferentes áreas, ¿sí? Áreas en ingeniería, áreas en negocios, en administración, cuerpos académicos conformados con profesores, siendo que pueden hacer un match en el que se pueden lograr trabajos o desarrollos multidisciplinarios, ¿no?
Claro, muy concreto esto, porque pues la verdad a veces el reto es que estas metodologías se puedan masificar y se puedan aplicar a diferentes niveles de la educación, ¿no? Pues bien sabemos que cada vez salen más formadores, pero no sabemos si están aplicando estas metodologías que hacen parte de una investigación paralela. Doctor Zavala, además de eso quisiéramos que usted nos regale un correo de contacto para que las personas que quieran hacer alguna pregunta o tengan una inquietud y quieran hacerla directamente, pues puedan contactarse.
Sí, claro que sí, lo puedo poner en el chat, puedo dejar mi correo, y ahí, bueno, pues podríamos ahondar un poquito más sobre esta metodología.
Listo, la voy a dictar porque pues, las personas de YouTube no
Claro
la
que
van a ver. Es Johnny Zavala, que es con J, sin H, JONNY, punto Zavala con Z y V, @ upq.edu.mx. Entonces, para los asistentes que de pronto tengan la inquietud o quieran contactarlo directamente, lo pueden hacer a través de este correo electrónico. Doctor Zavala, de verdad estamos complacidos de haber contado con su presencia en nuestro congreso y esperamos que en una próxima oportunidad también usted nos pueda ilustrar con los avances de este proyecto y otros que tengan abanderados en este momento.
Muchas gracias, Carlos.
Perfecto, de esta manera damos cierre a la sala 3, temática tópicos de enseñanza de la física. Le damos muchas gracias a todos los asistentes por habernos acompañado en esta sala temática y les invitamos para que se vinculen nuevamente a la sala magistral. El enlace lo encuentran en la página del evento. Soy Carlos Martínez, locutor del CST, y les acompañé hasta este momento. Feliz tarde.